This problem is number 23 from the 1994 chapter Mathcounts sprint round. And it is a tough problem. And there's a couple of ways you can do it. First way is to really just what we say, bash out the problem. And so we start with 2, and she hits the key, and the 2 becomes 8, because 2 to the third power, 2 times 2 times 2 is 8. And then you can do 8 to the third, which is going to be 8 times 8 times 8. And maybe some of you would know what that is, but that's something that most people don't know, that 8 times 8 times 8 actually turns out to be 512. And at this point, it starts getting pretty tough because you've got to go through and you've got to multiply 512 times 512 times 512. And so when we cube it the next time, we get 512 times 512. Well, this is where estimation skills can really help you out. If you take 512 and make it just 500, that multiplies together a lot easier, and you end up with, well, 250,000. If you do the 2 zeros and then 5 times the 2 zeros and then the 25. And then if you do 250,000 and you multiply by 500 again, you get 1, 2 zeros again, and then you get your 4 zeros, and then you get 125 at the end, and so that gives you 125 million. So hitting the key once, twice, 3 times, end up with 125 million. Now clearly, when you cube this huge number, so this 4th time, you're going to get a number greater than 1 billion. And so that's a nice way to do this problem, and it was made much easier by using the estimation of 500 instead of 512. Certainly, we're introducing error into the problem, but not 875 million error. It'd probably be much, much smaller than that. The other way you could do this is to realize that it's hard sometimes to cube things, but if you do them in scientific notation, it can be easier. So for instance, if I cube this, I get 2 to the, oh, that's not 20, so this is to the 0. So I get 2 to the third to the 10 to the 0, which is 8. And then if I cube that, I get 512, but then I can make it 5.12 times 10 to the 5th, or 10 to the 2nd, because that's in scientific notation. So when I cube this, well, it's whatever this cubed is, and that's about 5, so about 125 times 10 to the 6th. 10 to the 6th is a million, and so it's 125 million, and so you can see where then you have to cube it a 3rd time to get to your billion, and it actually is way above billion, because when we cube that, the 125, it's to the, you multiply the 6 times the 3 and get 18, plus 125 is really huge. So it's way, way, way above billion. So either way is a good way to get 4 as a number of times you have to cube it.